So this whole thing is 693. So half times base times the height V gives you 693. So if you know this, then you can find the answer. (16.5). So the highest speed is 16.5 meter per second. Okay, next, they want you to find the acceleration in the first 34 seconds. So acceleration is the gradient of the graph. So gradient of the graph is rise over run. So the rise is 16.5 and then the run is 34. So acceleration is gradient. So if you are asked this kind of question, you should be happy because divide by 34. Okay, you will get 0.485 meter per second square. Okay, very direct and clear cut. So if it's speed time graph, remember these two things. Even if I ask you for the speed, if I ask you for the acceleration when t is equal to 17, what do you think the acceleration will be at time t equals to 17? What is the acceleration at t equals to 17? Still 16.5, still 0.485. Because the entire line shares the same gradient. No matter where we are talking about, the gradient is the same. You can leave it as fraction. So if you prefer 33 over 68 also can. Okay? So no matter where I say, as long as it is on that same line, the gradient is the same. What if it's exactly 34 seconds? Then it will be this gradient. It will still be same calculation. So no matter which rise over run I find, it's the same gradient if it lies on the same line. Okay, but what if I want to find this speed? What if I want to find this speed? Then your similar triangle will come into play. Can you see your similar triangle? So if I want to find partial speed, that means at 17:34, this part here, I know is 16.5. I want to find this. So use similar triangle to help you. V over 16.5 should be equal to 17 over 34. Okay, then you cross multiply. Usually when they draw, right, for speed time graph, your acceleration is either this, this, or this. It will be straight line. They won't ask you to find acceleration of an increasing curve. Distance is? Yes. So only these two things for speed time graph, take note. And then if they want, they not only can test you acceleration at end point, they can test you acceleration at partial point. They can test you speed at partial point as well. So these are the different scenarios.
So that one is just gradient?
Yes, gradient and similar triangles. Okay, so this is a recap of chapter 5.5. So you will realize the popular one they like to ask is usually what? Speed time graph, because more exciting.
What do you mean exciting?
Because easier to... do you all know how to sketch this? If I ask you to go back to the distance time graph. Increase uniformly, then decrease, like that. Do you all remember? Yeah. Sorry? Everything in the chapter is possible. Okay, I remember that part of the chapter I asked you all to sketch, right? Yeah, so but O level rarely ask that though. Okay, so last two example. Okay, so go and simplify everything. This is 30 V B plus. Because a trapezium, you remember, is sum of the parallel lines. So half times sum of parallel lines times height. Okay, area of trapezium. Yes. Sorry? Here, this one, the red one. Okay? So 30 plus 600 plus 40V plus 75. So go and simplify very quickly. You get 30V is 375. So V is just 12.5. What thing 0.4? This one, speechless. Okay? So this one is just like that. Making use of area. The only difficulty they can add in is there's a difference in the distance covered. But the rest are fundamentally the same. Okay? Yes. The height is 60. Yeah, correct. So I put 60, but I cancel with the half. Become 30. Marius, what are you doing? Okay, last one. Last one is a similar question to, okay, if you see, this is the question that came out last year for distance and speed time graph last year. So the next one I'm showing you came out in 2021. Okay. Yes. Find the area under the graph and then fulfill this statement of 75 meters further. So if you know this, you can do. It's just area of whatever shape you see. Okay, last example. You can leave it as 1/4. Also can. But remember, the rise is not 10. A lot of you will use 10. It's only 5. Okay, out of 20. Okay, next one is they tell you that the area, they want you to find the distance traveled by T. By B in T seconds. So it's this one. Raj. I can hear you. Okay. So find the area of the green part. Okay, which is area of rectangle. B part 1. So it will be 8 times T. They say leave it as an expression in terms of T. So just give me 8T will do. Okay, then they say at time 0, at time equals to 0, okay, at the starting point, your A is already 90 meters behind. A is here. Okay, when time is 0, A is 90 meters behind B. And then at the end of time T, the two of them meet. So this is your B. This is where your A is. So in other words, I need to be able to find the distance of B, which is the area under the graph. I just found it to be 8T. Okay, it will be equal to distance of A, okay, plus that 90. Okay, A must cover the distance. Okay, we are distance of A. Okay, take note. A must cover what? A within that time T, right, must cover 90 as well as the distance of B. So A must cover this one plus the 90 meters. Can you see that? Because at time T, distance A must already cover the 90 that it falls short of.
Okay, that's pretty impressive.
So you must be able to see this, then you can do the question. Yes. Okay, at time T equals to 0, A is 90 meters behind T. That means my starting line for A is here. But by the end of T, I must reach the ending line same way as B. So the distance traveled in time t seconds by distance A is B plus 90. Can you see that? So the total distance that A needs to travel in t seconds is B plus 90. So when I write this, it is the equivalent of this. Okay, distance A must be 90 plus 8t. So how do I calculate? My distance A is again a trapezium and a rectangle. Trapezium, they like to test trapezium, don't know why. Okay, and a rectangle. So what I will do is I will find the trapezium, half times sum of parallel lines, times the distance here 20, plus the rectangle t minus 20 times 10.
Sure.
Yes.
You have to get 20 square plus 5 square.
20 square? This one is 20, right? This one is 5 and 10. This one, the bottom here is t minus 20. The top part here is 10. So that's how you find the area. And it must be equal to 90 plus 8t. Yes. When it passed through it at that time t, it means they meet at that point. They are exactly at the same part. So within that t seconds, A needs to cover the distance covered by B plus that 90 meter he or she fall behind. Okay? So when you simplify the expression, 90 plus 8t, this is a 10. So 150, 10t minus 200. Yes. Because A needs to cover these two distance within t seconds. Yeah. So this is 2t plus the 50 over 140, is it? 150 minus the 200 is minus 50, bring over 150. Okay, can. So t is 70 seconds. Okay, so I hope that over the years you roughly can estimate what they can ask you already. Yes.